Hello, I am Moses Gumadi, and in this video I want to talk about how to leverage advanced analytics in operations excellence. One of the best examples that I could think of where this is really put to use, advanced analytics are really put to use in the operations, is the Formula One racing operations. They've got two strands of things going on. One is the racing operations execution going on live, with the car racing and the support team supporting and making decisions, etc. That's one thing going on. And then they have on the back end the racing operations redesign team to make sure that they continually improve the process and the setup. Right. Now the way it works is that the car is fitted with a lot of sensors. The tire pressure, fuel, how much fuel is remaining, the temperature of the brakes, the temperature of the engines and the exhaust, and humidity and the wind speed. Lots of sensors are fitted into this car, and this data is logged in and sent to the station, where they use this data to predict real-time issues. Now, the algorithms that support this issue predictions are obviously already employed. The determined and deployed. We'll come back to the question of how are they determined in the first place, but they're deployed. Right now they use these issue predictions and then make the decisions such as, hey, it's now time to stop by, come back to the pit at the next stop, we'll change your tires or we'll fill the fuel, or whatever those operational decisions are. They make those operational decisions and make sure that the outcome that is supposed to be achieved is maximized. The chance of that is maximized. That's the intent. Now, once the race is over, obviously the data that is collected during the race, including the sensor data as well as the predicted and actual encountered issues during the race, will be logged in, and that will be analyzed to identify redesign opportunities. When we say redesign opportunities, we're talking about the redesigning of the algorithm, redesigning of the methods and the operating procedures, and redesigning of the parts, sub-assemblies in the car, etc. And before they deploy these new methods, new parts, new algorithms back into the operations, they also do simulations, simulate the actual real-life scenario to see really if these changes work. And once they are satisfied that these work, and they deploy them back again into the operations. And so in the end, they have an improved, redesigned car or car parts, redesigned methods, and redesigned algorithms, etc. This is how the whole thing works. And these things have to be in a closed loop, as in, one thing has to feed back to the other. And so they have a closed loop integration of the predictive and prescriptive and descriptive analytics for the whole operations. So this is how it works as far as the car racing operations are concerned. Now, car racing is a highly dynamic environment. The variation of the external factors is huge when you compare it to a regular, say for example, when an aircraft takes off from London to New York. In order to manage that, that's not really that difficult, given that the predictability is quite high, and there are not many parameters that would change, as in the case of car racing operations. How can we use this sort of learning from this example and apply into the regular operations in the businesses, such as in banking, insurance, or utilities, and the consumer goods, retail, manufacturing, all these, service, all these businesses? How can we leverage the predictive, prescriptive, descriptive analytics to ensure that we achieve operations excellence? Right, so let's talk about operations excellence. Now, you see, I want to show three areas. Now, we talk about the external variables. We just talked about the external variables earlier. So every organization, every set of operations, right, they have external variables, and they have their operations which are actually running, which deliver customer value. So coming from the customer, now how you set up your operations and how you configure your operations strategy in order to deliver value to the customer depends on these four factors: timeliness, cost, quality, and variety. Now, different companies choose to compete in the market differently by playing with these in the space of these four parameters, and they try to gain a competitive advantage. Now, depending on how you deliver on timeliness, cost, quality, and variety, you would generate an economic profit and then deliver the customer value. So obviously, customer value delivers the shareholder value in terms of the economic profit. Now, to deliver what is supposed to be done according to the operations strategy, then we have to organize our operations in a certain manner. And the building blocks of the operations are obviously the process flows and the activity networks that exist within the operations. Also, the human resources. Who is deployed, what skills, what kind of people are deployed where, and what is the capacity, etc., and the number of people. Facilities and assets, hardware and software, right? Where, what capacity, and how are they configured, etc., and what is their availability, what are the issues. So this is a major building block as well as far as operations is concerned. Finally, the material and information supplies that come in and pass through this network. That information is required for the overall governance of the operations. Right. Now, all these operations function to deliver the value that's on the right side in an environment which is dynamic. And so you have these external variables where demand, regulation, market, and risk factors are varying. Demand variation, seasonal as well as sporadic variations, would cause your operations, there's a requirement to update your operations or rearrange certain things, capacity decisions, etc., in order to ensure the value is delivered to the customer. So similarly, regulations will require change in the operations. Market conditions would require updation in the operations, etc. So that's the external set of variables. In this environment, how and where can predictive or advanced analytics work? What kind of data do you first of all log in, as we saw in the example of this racing operations? So, as far as external variables are concerned, so you could log in the demand sensing, demand data, upstream demand intelligence beyond your value chain, or the customer interaction data before the sale is made. So some of this information could be used as a data, and then transaction monitoring to ensure that regulation and compliance are met. Process monitoring to avoid risk factors, etc. This data could be logged. As far as the operations are concerned, again, upstream intelligence, what's happening upstream could be used, that data could be used to make decisions in the downstream and make adjustments. People, process, and machine data, their availability data, their deployment data on a dynamic basis, if that's available, that helps in making decisions as well. And of course, you could fit in sensors, especially for predictive analytics or for a lot of other purposes. We can get into this in deep, but I'm just trying to give you an overall framework here. So you could fit in sensors. So these are your data sources, the types of data that you could gather in the operations. For the customer value itself, right, you have got channel data or funnel data. If people set up marketing funnels where people come in through different channels, they click the pages, or they place an order, they abandon the cart, and all these sort of things that's going on as far as the channels are concerned and the funnel setup is concerned, that data can be also of great use. Also, customer profiles, what kind of people are buying, where are they, how much are they buying, what kind of things are they buying together. All this data could help to make decisions. And buying behavior, what kind of things together are they buying is what it is. Feedback and complaints. What sort of interactions are they making with the company? Also is a good data source. Now, using these data sources, we can make these sort of decisions. Capacity decisions could be taken, and prediction of fraud and preventing of non-compliance could be done as far as these external variables are concerned. Now, within the operations, the sort of decisions that you could make using the data could be like you redesign operations, or also make decisions on the fly, such as like dynamic resource allocation, dynamic buffer decisions. There are 3 types of buffers. I mean, that's probably in another video that I could talk. But there is a capacity buffer, time buffer, and work and inventory buffer. So there are 3 types of buffers. So you could make dynamic decisions in order to smooth your operations as the data comes in, as the dynamic variables change. Also, predictive maintenance. So these are some of the decision areas with the data as far as operations is concerned. On the customer side, you can make decisions of upselling, cross-selling, even downselling. For example, somebody may be coming to the website, trying to see things, or maybe bought something once. They are in the system, but they haven't bought recently. And so, you could identify all these opportunities, including downselling, if required. Prediction of churn. And opportunities to reach out could be figured out. Also, personalized interaction with the customers could also be a major decision variable as far as this setup is concerned. So really, the framework, the way it should work is, our purpose is to determine the right set of variables, those timeliness, cost, quality, and variety. How do we want to operate in that space to ensure that the competitive advantage is maximum and we deliver maximum economic profit? Once that strategy is determined, we need to ensure that the operations are designed to deliver those numbers and deliver that value. But if you design and keep it static, that ain't going to work, because the external factors are dynamic, and therefore you need to keep on that change within the operations to ensure that responds to the dynamic changes outside. And so this is how you gather the data then from all sides and make dynamic decisions during the operations, much similar to the car example. So when it comes to the actual industry sector applications, how does it work? Now, I've got there on the screen 3 areas at least: power and utilities, consumer goods, and retail banking. So in these 3 areas, I have shown various things that one could do as far as customer value is concerned, within the value network or the operations, as well as the external variables. So let's look at some of the examples here. Churn reduction, complaints management, basket analysis, loyalty management, spending patterns, lifetime value, etc. They're all falling under that customer value bucket. Within the value network, of course, there are a lot of them. So space, route optimization, outage reduction, operational risk in the banks, etc. Improving underwriting models in insurance, mortgages, etc. Also, as far as external variables are concerned, shelf demand sensing, fraud management, collections, predicting theft in energy in the power industry. These are some of the various examples that you could apply as far as the real life is concerned. I trust this video is useful to you, and if you have enjoyed it, please do comment or like it, and thanks for watching.